My name is Daniel Blackburn, and this video is part of the course SWAE2201 Introduction to Soil and Water. Today we're going to talk about soil sampling and soil sampling strategies. So let's get on with it. When you think about soil sampling strategies, you first have to think the reason why you're sampling. So if you're sampling to describe a soil profile, you want to sample each horizon individually, and you want to take fresh soil samples, and also you want to take volumetric samples for bulk density. And but if your reason is to describe the spatial variation of any specific properties of the soil, then you're thinking about making either a grid or a transect. So a grid will look like the figure on the left, and a transect will be a line with samples taken at specific distances. The thing about the describing spatial variation, you want to bring it to mapping or graphing this property, so you need to know exactly where is the position of each one of these samples. But most often what we do is we want to guide farmers' decision with the soil properties. So your sample must reflect the properties of the whole field. So what you want to do in this case, you want to sample the first 20 centimeters or 15 centimeters depending on the country that you are, and you want to make a composite sample, which means you want to sample several samples, combine them together and take a subsample of this big sample. And that composite sample, which represents several individual samples, that will represent also the whole field. Here is a sketch on the map of a zigzag pathway sampling the whole field here, and sampling two plots individually. Here on the bottom you would see the first plot, and on the back you see the second plot sampled and made composite sample from one of these. So the type of design that you can take for this kind of sampling, of course, if you think in individual samples, it could be simple, random, or systematic. But if you're thinking about the design, then you can have also you can have the stratified sample, which can be in zigzag or can be also in a grid form of sampling. So how often should you sample? In general, you should sample every year or at the same time of the year if you want to be consistent with the monitoring of your properties. But in some long-term cultures, you can sample every 2 or even every 4 years. But high-value crops should be sampled every year. And what the sampling tools that you're going to use are usually an auger. So you have different types of auger here illustrated, and the one on the left is the coring auger, which takes a small amount of sample, which is very useful. So you don't want, if you're making a composite sample, you don't want to end up with a very big sample, which is hard to subsample and carry around. So this auger here on the left will be the most adequate for fertility recommendations. But if you need more volume of sample, of course, these other types of auger will be adequate for different texture of soils. So the hand coring auger, that's the one that I was showing before. You just push it into the soil, and the soil will form this column. And then from that column that's sample inside the auger, you can take the first 15 centimeters and put it on the bucket. All the soil that goes on the bucket will later on be mixed and subsample for taking the composite sample. So if you're using a spade, if you don't have these augers, you can also do it, but what you have to do with the spade is, first of all, clean the surface of the soil, make an initial hole on the soil, and then from that hole you take a slice, like here is exemplified here on the right, and from that slice you're going to take the first 15 centimeters, put it on the bucket, and continue doing that until you have the whole plot represented for taking the subsample of the composite sample. Here a good illustration about how this works. And if you take a slice from the soil or a hand coring auger, and then you put all that into the bucket, a plastic bucket, and then from that plastic bucket you're gonna mix, and then you're gonna transfer some of that to the sampling bag, and then send that for analysis. And then what you're gonna do with that before analysis is put it for air drying, and then sieve into 2 millimeters in order to have that prepared for the analysis. The soil that you will analyze at the end is the soil that is has the particle size below 2 millimeters. So you can then, with the amount of material that's retained on the sieve of 2 millimeters, you can calculate what's the percentage of gravel in that soil. Yeah. If it's over the 35%, then you say it's a gravelly soil. Okay, that's it for today. Thank you.